right, so let's go ahead and go over these. So we'll start with the slope. What happens is the slope gets steeper, the evidence of the association gets stronger. So we can just sort of think about this intuitively, that if we have sort of a steep relationship between x and y, that means that a change in x has a big effect on y. That's going to be stronger evidence than one where you have a line that's, pretty flat, pretty close to zero. Another way you can see it is you can look at your t-statistic and notice that as the slope gets bigger, that's in the numerator, your whole t-statistic is going to get bigger, and bigger t-statistics means stronger evidence. As the sample size increases, the evidence of the association again gets stronger. And this is probably not too surprising at this point. We've seen this in lots of different contexts, but you can also see it from the standard error here, right? So as your sample size gets bigger, your standard error gets smaller. That's going to make your whole t-statistic bigger. These last two may be a little bit less intuitive, so we'll think about these a little more closely. What happens as the standard error of the residuals increases? So as the standard error of the residuals increases, your evidence actually gets weaker. It may help to look at a picture to see how this works. So standard error of the residuals, that's basically telling you how much spread you have around the regression line. So here, these two have the same slope, but there's much less spread in the first picture. So when there's less spread, it's easier to see the relationship, right? You have stronger evidence of a relationship in the first picture than you do in the second picture. Okay, and then the last one, what happens as the standard deviation of x increases? So it's the bigger your spread in your x's, generally the stronger the association, or the stronger the evidence of the association. So I actually kind of like to think about this opposite. What happens as you make the standard deviation of x smaller? So let's look at a picture again. So this is showing, a pretty reasonably strong association between x and y, right? It's pretty clear that there's a positive association there. But let's say that we restrict our x's and we only look at the high end of the scale. If I only look at the high end, now I really can't see much of an association at all, right? My evidence of an association has gone way down, and that's going to be generally true. And we can actually see this when we look at the formula for the standard error too. As the standard deviation of x gets bigger, the whole standard error gets smaller, and that makes our whole test statistic bigger.